Hello viewers, we are introduced to integral equation. Firstly, we see the definition of integral equation. An integral equation is an equation in which an unknown function to determine appear under one or more integral sign. That means, firstly, this is equation. What is equation? Ax plus b equal to c. This is equation because there is a unknown variable x. When we solve it, then we get x equal to c minus b divided a. So we can find the values of unknown variable. Now, what is integral equation? If a unknown variable, let's go please, u of x be unknown function. If we can write it, suppose 1 plus 0 to x u of t dt. If we find out u of x, we can use u of t. It is possible. Using u of t, that means u of x function, and now integrating of function and plus on equal to u of x. So interesting this. Here unknown, this unknown function appeared one integral equation. So this is the integral equation. If u of x equal to e to the power x, then we can write e of t equal to e to the power t. Now we integrate 0 to x e of t dt and plus on, what is the value of it? Equal to 1 plus, when we integrate e to the power t, then we find e of e to the power t. 0 to x the limit. So putting the upper limit equal to 1 plus e to the power x, and putting the lower limit then e to the power 0, that means 1. So this will be vanished by 1, so e to the power x, and e to the power x equal to u of x. So we can say that 1 plus 0 to x u of t dt equal to u of x. So it is correct. U of x equal to e to the power x be the solution of the integral equation. So interesting equation, integral equation. That's will be defined an unknown function to determine appear under an integral sign. When an equation in this form, then this equation is called integral equation. Now let's go please. What types of integral equation will be shown? Firstly, we are see two types of integral equation. That's number one, Volta integral equation. We can write it IE integral equation, and then second is Fredholm integral equation. Fredholm integral equation and Volta integral equation. These two types of integral equation usually we see, but the most interesting and Abel integral equation, this is singular integral equation. So this is most important integral equation. We will see another types of integral equation, that's called integral differential equation. It is not differential equation, it is integral equations. Now we'll see the example of Volta, Freedom, singular and integral differential equation. Firstly, we can write an example, that's e to the power x be the solution of u of x equal to 1 plus 0 to x u of t dt. This equation is called Volta integral equation because the integrating limit is variable. That means integrating limit is a function of x there. So we can write in the standard form of Volta integral equation. Suppose alpha of x and u of x equal to f of x plus lambda a to x, the limit kxt, which is called kernel u of t dt. This is the standard form of Volta integral equation. This integral equation is called Volta integral equation because the limit of integration are the function of x and the unknown function u of x appears under the integral sign. So this is called Volta integral equation. Now if alpha equal to 1, then this equation can be written as u of x equal to f of x plus lambda a to x kernel and u of t dt. This is the standard form of Volta integral equation of second kind. So this is second kind. We can write it second kind Volta integral equation. So alpha of x equal to 1, if then it is second kind. When alpha of x equal to 0, then the equation can be written as this form. This time, this equation is called the first kind of Volta integral equation. And if f of x equal to 0 and alpha of x equal to 1, then this equation can be written as u of x equal to lambda and a to x kernel x comma t u of t dt. This equation are called the second kind but homogeneous. So homogeneous second kind Volta integral equation. We introduce three types of Volta integral equation. That is the first kind and second kind and the homogeneous with second kind. So we'll discuss on this equation in the next video. Now we'll discuss the freedom. What is the freedom integral equation? We know that the integral equation must be as this shape, that means u of t and under and integral sign, and there are kernel and this is constant. We cannot write here f of x, so u of x. This is an integral equation. when this integral equation is called freedom integral equation, if the limit of the integral is constant. So the domain of integral must be constant, then it is called freedom integral equation. We can write a standard form of freedom equation as like as Volterra integral equation. When we putting this b replaced by x, so b is replaced by x, then this equation is converted to a freedom integral equation. That means alpha of x u of x equal to f of x plus lambda a to b kernel x comma t u of t dt. This is the Volterra integral equation. We write it clearly. That means alpha of x u of x equal to f of x plus lambda and a to b kernel x comma t and u of t dt. This is freedom integral equation. This is the most general format of Volterra integral equation. When alpha of x equal to 1, that means this is 1, then this equation is called the second kind freedom integral equation. But when alpha of x equal to 0, then this is the first kind. And when alpha of x equal to 1, then this is the second kind. And when alpha of x equal to 1 and f of x equal to 0, then this equation is called the freedom second kind with homogeneous, as like as Volterra integral equation. So we introduce three types of freedom integral equation: first kind, second kind, and second kind with homogeneous. Let's go please. The third number, singular integral equation. This is the most important integral equation which is derived by the Abel, well-known name Abel. Now we see a very simple example of singular integral equation. U of x equal to f of x plus lambda minus infinite to plus infinite u of t dt. It is very small equation. Here we see that the limit is infinite in both sides. That means lower limit and upper limit. When the infinite limit exists in integral format, then this is called singular integral equation. Need not on the both sides, only one is infinite, then this equation is called singular integral equation. We see another types of integral equation. If f of x equal to 0 to x 1 by x minus t to the power alpha u of t dt. Here alpha is restricted 0 less than alpha and alpha less than 1. At this time, this is the 0, that means x minus t is 0 in the interval. So this equation is also called the singular integral equation. Now, integral differential equation. What is integral differential equation? We cannot write in this space, so we use the previous equation to explain the integral differential equation. If this is absent in here, and we can write du dt, that means d dt of ux equal to f of x plus lambda a to b kernel as well as x comma t u of t dt. So this is an integral equation because u of t is unknown and it appears under the integral sign, but this unknown function appeared under the differentiation. So differentiation and integral both are present in this equation, as these types are called integral differential equation. These integral differential equations are two types: one Volterra integral equation and second the Freedom integral equation. So Volterra integral equation are three types. That's the first kind, second kind, and second kind with homogeneous. Freedom integral equation are three types: first kind, second kind, and second kind with homogeneous. Singular integral equation, we see there are two types. That's when the limit is infinite, then this is called singular integral, and when the kernel is not that the kernel is infinite, when kernel is infinite between the limit of integral sign. So, and the integral differential equation, these exist of determinant of unknown function and integral of unknown function. So these are integral differential equation. This is very interesting equation. Now we will see that if phi of x equal to 1 minus x, this is the function, and 0 to x e to the power x minus xi, phi of xi dxi equal to x. We see that this is an integral equation because the unknown functions are under the integral signs. So please listen to me. The question: show that the function is a solution of the integral equation. We take it very simple way. Phi of x equal to 1 minus x. So phi of xi equal to 1 minus xi. That is very simple. And putting these values in here, then we can write that 0 to x and e to the power x minus xi 1 minus xi d of xi. We can write on the left side. If we integrate this in partial integral formula, then we can write it 1 minus xi and integrate this with respect to xi, then we can write x minus xi and minus here, putting the limit 0 to x here. Now let's go the second term. According to rule, this is minus. When we derivative these terms, then we get another minus. When I integrate these, then we get another minus e to the power x minus xi, and integrate this as well as 0 to x limit. So when we calculate these terms, then minus 1 and minus 1 multiply and vanish each other. Then we integrate only these terms and we get another negative signs. Then it is easily to say that this sign is changed to plus e to the power x minus xi, and lower limit and upper limit 0 to x. So now we want to putting the upper limit and lower limit in these terms. So putting the upper limit of x in these terms, then we get minus 1 minus x e to the power 0. And when we putting the values of xi equal to 0, then this is minus, but according to the rule there is a minus, so 2 minus are made plus, so 1 and e to the power x. So next, when putting the values of xi equal to x, then it is e to the power 0 and another e to the power x here. So very simply x minus 1 this terms in getting from this, and this is e to the power x, this is 1 minus e to the power x, so e to the power x and e to the power x vanish each other and these are vanished, so this is x and this is equal to the right hand sides. So we can say easily phi of x equal to 1 minus x will be the solution of the integral equation.